Welcome to the All Digital AM podcast. Continuing the conversation in 3D printing and advanced manufacturing, my name is Adam Penna, and my guest today is Rick Neff. Rick is out of Cincinnati, Ohio. And Rick, how you doing today?
Doing great, Adam. How are you?
Good to have you here. I know you've been a heck of a 3D printing and marketing consultant for a while, and it's good to talk to you because you not only have that sales and marketing background, but also hands-on engineering experience for a while in the industry, and that's a big asset to being able to consult and actually work with people along their way. So happy to be talking to you today, and good to be chatting always, Rick. Always good to see you.
Yeah, it's always fun hanging out with you, Adam. Wish we could do it in person.
Yeah. We actually hung out a bit over here in Austin. We were just talking about that, and there was that Austin forum here that was the start of the big things to come, and it was good to see you there, and good to have things happening in here in Austin. There's a lot going on in additive manufacturing. And I know you got a lot going on in Ohio. So we've been talking a lot over the last couple of years. And I know, let's talk a bit about your background as we get going. I know, like we talked about, you have a BSME in the fluids mechanics and business, and you threw photography in there too. So a bit of that side of it. And you've been working for a while with the background going back to, I guess it was Ingersoll Rand was the first.
I started out after engineering school, went to Lehigh University, got a Bachelor of Science in Mechanical Engineering, and my first job was working for Ingersoll Rand. I worked in sales for them in San Francisco, LA, and Buffalo, New York.
Buffalo, where I was born.
Yeah, we got lots.
That's awesome. Buffalo, Niagara Falls area, man, great place.
And so I had a sales territory there with over 1,000 customers. So basically had a crayon line on the map in a company car and was making sales calls almost all day, every day. From there, I went to the aerospace world and worked for two aerospace companies, EG&G Wright Components in Phelps, New York, which made aircraft engine fuel valves, which I was responsible for selling. And then Amatec Aerospace Products. You've got some Amatec in your background too.
Sure do. Little crossover there also.
Yeah. And so Amatec bought GE's instrument products operation in Wilmington, Massachusetts with the idea of, hey, if that's not a GE company anymore, we could sell all those aircraft engine sensors to a new customer, Pratt & Whitney, that's a couple hours down the road. So I signed on there to sell to Pratt & Whitney, and that was just a whole lot of fun. I'm selling liquid level sensors, mass fuel flow transmitters, thermocouples, speed sensors, for aircraft engines.
That was all before, like, even that you got into the long-term experience, right? At CI Cincinnati Incorporated, correct?
Yep. Yeah. And then in 1993, I wound up at Cincinnati Incorporated in the laser department as a product specialist. And what I did was I went out on the road with salesmen and distributors and helped them do presentations on laser cutting processes and then closing orders for machines that were typically $500,000 or more. So that was fun, did that, and then managed the applications group and the product for them for a while, and then got into business development. And that's where I got into additive manufacturing because I found this really cool technology at Oak Ridge National Labs to do large-scale additive.
What was that large-scale additive application?
So what they had is they had a robot with an extruder on it that had come from Lockheed Martin, and Lockheed Martin was trying to 3D print aerospace tooling with it. They were having a little trouble programming the robot because, robots are really good at moving from point A to point B, but following a specific path is a little bit of a challenge for a robot to get all those axes coordinated. And then if you're doing additive manufacturing, what you've got to do is you've got to deposit or you've got to move along that path at an exact speed or you don't deposit the right amount of material. And then also in additive, you wind up with maybe 1,000 layers in a part. So that's a different program or different path for each layer. And the programming just blew up. Couldn't be done very easily back then. So what they did is they took the extruder off and put it on a blue gantry they had there that they'd been using for printing concrete long time ago. And they were very quickly making good parts. And so they were excited. Lockheed was excited. And they're like, this is great. But Oak Ridge didn't want to build 3D printers, and neither did Lockheed Martin. And I worked for a machine tool company, and I saw that, and I'm like, oh, this would be easy for us. We've got this laser cutting system with linear motors and a lightweight gantry. We could put an extruder on it and make a 3D printer pretty easily. So kind of threw the concept out to my company and Oak Ridge, and Lonnie Love from Oak Ridge came up and saw the laser cutting system. He's like, turned to Craig Blue. He's like, I got to get one of these. This is awesome. So we worked it out, signed a cooperative research and development agreement with Oak Ridge. And the Department of Energy is awesome. They will throw money in a pot to help develop new technologies as long as the company that they're working with has a similar amount of skin in the game and is willing to commercialize it. So we signed a CRADA with Oak Ridge in February of 2014. In March, we delivered a machine. In May, they were making parts. And in June, we got our first order from Sabic for a machine.
You talked about that because the time at, Cincinnati Incorporated, you were there 26 years plus. And, coming in on the laser side and building those things up. And then, so you talked about that point of talking to Oak Ridge. What time period was that? Like, I guess, how long did it take for Cincinnati Incorporated to start to see, and what was their reasoning, I guess, like where, when, and why did all of a sudden additive manufacturing become something as a viable thing to pursue for Cincinnati Incorporated? How did that start up, I guess, that adaptation of AM?
Yeah, well, it's interesting because in market development, my job was to look for new technologies to bring into the company to help our existing products or to find new markets for our existing technology. And this was sort of in between. It was a combination of both. And so we were interested in additive manufacturing because, back in 2013, 2014, it was just a hot subject. I mean, everybody was interested in additive manufacturing. And it was a bit of a stretch for us because, we weren't involved with polymers. The equipment that Cincinnati Incorporated makes, we're known for probably making the best press brakes in the world. They make great laser cutting systems. They make powdered metal compacting presses for the automotive industry. And they make shears for shearing metal. So it's all metal. So adapting a polymer application was something totally new.
Yeah, it is. And that's crazy because it's like, I ask about that and I think about, for people that are listening too, as far as like that adoption phase, and you hear a lot of, even in the last, 5 years, a lot of companies looking at their inventory of parts, seeing where things are useful. And you've seen that as a consultant too. There's been that growth and adoption, and it's scaling at this point. People that are looking into, hey, where's our part catalog? What can we do? Ties into the supply chain a lot of times, what actually is feasible now to pick up with additive manufacturing and start to do certain things, either from benefits in the application itself or for benefits along the supply chain and somewhere in between. It just depends on the application and the actual customer out there. But there's that adoption phase of where you start to look at what is actually viable for additive. And being a digital process now, and the way that things are going and the way that things are become valuable inside of just inventory not being physical anymore, there is a lot of that going on, and so it was just from your experience, I was always, I had never been at a company that just adopted, the AM, I've been for companies that are actually CAD companies, companies that are actually producing the machines, but actually working for a customer who's actually adopting the AM. And to see that come into play over years of why and how that's happened and what their actually view was of taking it on. And I'm sure there was we don't need to do that, kind of a thing. But you worked through that, there. So
yeah, it was a really interesting time because, you looked at it, it was a new technology completely to print something on that kind of scale.
Yeah.
And so what could you do with it? And so like a lot of 3D printing or additive manufacturing, there's a lot of technology out there that are great solutions, but it's like, what application are they good for?
Right.
Finding that was really interesting. Where were the applications? And as it turns out, Lockheed Martin's idea in the first place was probably where we found the most success. And so what they were trying to do was print tooling for composite manufacturing. As it turns out, that's probably one of the biggest markets for the BAM system or large format additive manufacturing is to make tooling. Everybody kind of wanted to make tooling that would go in an autoclave, which is really cool. But, we're talking about printing thermoplastics that can withstand autoclave temperatures of somewhere around 350 degrees Fahrenheit. In an autoclave, typically the composite parts are laid up on a tool that has the shape of the part that you want. You then take these layers of composite material, which are typically carbon fiber with some resin in it. that will cure at temperature. And so you take these layers and build up a part. So it's additive manufacturing when you're doing composite manufacturing, because you're adding layers to the part as you're building it. And then you put a plastic bag over it typically and suck all the air out of that plastic bag so that it consolidates the composite material against the tool. You then put that tool in what's known as an autoclave, where it heats up to through a curing profile for the resin, and also is pressurized to maybe 100 psi to help further consolidate and drive any bubbles out of the composite part. Turns out it's a little hard to print in high temperature thermoplastics because you got to print really fast. You got to print before a part cools off. A really cool application is in trim tooling. Wow. So once the part comes out of the autoclave and you take it off of that tool, it needs to have holes drilled in it in a precise location. It needs to maybe have cutouts done. It needs to have the outside trimmed. And so what you need is a really accurate tool that you can place that part on, maybe hold it on there with vacuum, and then come in with a 5-axis mill and trim the part. So we had customers that were basically making these trim tools. The trim tools are the kind of thing that they're kind of large, and they may go through a production run and use them for a while, and then they'd sit outside the aircraft manufacturer for months or years before they're needed again. Well, sometimes just storing them is a pain in the neck. So if you can 3D print them and you could make a tool in a few days, there might not be a need to store them. So there was some success there too. So that was exciting. Learning a whole new industry after, being in aerospace components and metal fabricating, learning the composites industry was fun and interesting.
Oh yeah. And we see a lot of great things happening with composites continually. It's the hypersonic side of it is really getting interesting too, and what's happening there now. So also, talking about what happened there since they're incorporated and going post that. I know also you still working with Firehawk Aerospace. Tell me a little bit more about that and how that's been for you.
So Firehawk's a really interesting startup company. They make hybrid rocket engines. And you're like, well, what's a hybrid rocket engine? Well, we look at liquid fuel engines that have liquid oxygen as the oxidizer. And then they have a liquid fuel that's something like kerosene or liquid hydrogen. And those fuels are mixed together with high pressure turbo pumps. Of course, they're cryogenic, some of them really cold. And they combust in a combustion chamber and come out of a nozzle. Then we have solid rockets, which you take a solid propellant and you mix it with a solid oxidizer, pack that into a tube. And when you light that, you get it all. You get it now. And it's you got to make sure that you don't have any sparks or anything like that in the process because you can ignite your rocket when you really don't want it to be ignited. And then there's the hybrid rocket, where what we have is we have a solid fuel, and then we have a liquid oxidizer. And typically we use nitrous oxide for the oxidizer. And the fuel grain looks like a cylinder with a port or tube down through the center. And the nitrous oxides introduced at the top. And the fuel burns from the center outward and goes out the bottom through a nozzle. And we can turn off the oxidizer and turn the engine off. We can throttle it. We can relight it. So it has a lot of the advantages of a liquid fuel rocket, but with a very safe fuel. And the fuel is essentially ABS plastic. So we 3D print.
What was that last part you said? The fuel is essentially the ABS plastic?
ABS plastic. So it's the same material we make computer cases and Lego blocks out of. So we've got a rocket engine with fuel in it that's, about as dangerous as a tank of laughing gas and some Lego blocks.
Yeah, well, there's a lot to happen inside of petroleum, as we all know. So, there's a lot of different risks inside of there and benefits.
Yes, absolutely.
That's really interesting, and where are they located again? I know they have a couple different locations, correct?
They've got a couple locations. They're essentially just north of Dallas-Fort Worth area.
Right. Yeah, just out of north side of Texas here. And probably about 3 hours or 2.5 hours from me. So a lot of great things happening in Texas. Yeah. So also what I wanted to get to, and we've all been through this, everything that's been going on since 2020, and you've been doing a lot of the, working with people and consulting, working in the industry before 2020 and after. So, think about what's changed there, and also what's stayed the same, from your experience, what's been going on, I guess, up until using 2020 as a changing point. So what do you see as the things that have changed and the things that have stayed the same inside of additive manufacturing?
That's an interesting question because you talk about that 2020 cusp, and you and I had a shared experience working with AFME. And what we did was we were working on creating some new events for the additive manufacturing space. And we were incredibly successful to start out with because we essentially were doing digital events, and we had some really great talent and put together some incredible events.
Yes.
That really capitalized on the technology that was available during COVID. We were all stuck at home, and everybody wanted to get out together, and the Remo platform enabled us to throw events where we could put on presentations and we could network, and that was a whole lot of fun. Today, I think we're back to doing live events, and live events are so much fun. That's one of the places where I get my energy. I have customers hire me to work in their trade show exhibits to help promote their things at live events. So it's awesome when you get to go out and see your friends and customers in places like Rapid or Chemex, which is the composite manufacturing industry show.
Yeah, great show. Great show. Yeah, there's a lot of different industry things happening with organizations, and also, just things that people have out there to learn from and to educate themselves on what's happening. The latest technology in one spot, that type of thing. It's hard to get those educational experiences without going to those shows, because you could see, in person, talk to people, and actually get an idea, a sense of where the technology is and where it's going, and see some of the demonstrations right in front of you. That might lead to that's part of the sales process, hopefully, that, you get a little bit more understanding in person at those events, and that leads to bigger conversations where you actually go and start developing things inside of projects for facilities and companies. That's always been the challenge there too, is that education side of it. And also not only talking to the same people or just talking to the people in the industry, but growing that message outside of the same ecosystem that we all have, inside of additive manufacturing or manufacturing in general. So that's always, I see, the challenge, but also it's what happens when you go actually physically to a show. You kind of get the education, hands-on things kind of progress forward, or you hope they do, because of the education that happens in those situations. I guess what I'm getting down to is like the challenge you see in educating people, and then also taking that education into implementing it, because of course it depends on the company or the project, but there's always, there's always, I guess, the naysayers, the people, we've been doing it this way for 20 years. Why should we change, kind of an attitude? So you have to go along with that educational phase, right? And then get to where it implements or where it fits inside of them. So talk a little bit about those challenges, if you can, and what have you seen kind of happen with, getting over the obstacles to education and implementation.
Yeah, in the composites industry, where innovation is pretty much the name of the game, it's kind of straightforward to look at. If you're making tooling which doesn't fly, can you replace a conventionally made tool with a 3D printed tool? And for trim tools, it's pretty straightforward. For autoclave tools, that's a little more challenging, but that's pretty straightforward. When you look at adopting some of the other technologies, it depends on kind of the qualification level you need for the parts and things like that. I think that the big success a lot of the time has been in the service bureaus or the job shops, because I talk to companies all the time about adopting additive manufacturing and how do you start? And everybody sort of is like wants that shiny machine that they're going to go out and buy. But buying a machine is not always necessarily the right choice for companies. You need to build up your capabilities in all the areas of additive manufacturing. And so that's CAD, designing for additive, CAM, slicing and preparing the computer program for the 3D printer, understanding and optimizing the 3D printing process, figuring out how to post-process the part. What do you do with it when it comes off the machine? It rarely looks exactly like the part you want to use in the final application. So gaining an understanding of all those different areas of technology are a challenge. And you could just go out and hire a really good team of professionals that have done it all already, and there aren't very many of us. So we need to kind of figure out, how do we share that information, and how do we get people educated on that? So there's other things you could do. You could start by buying a little entry level machine. a fuse filament fabrication machine and just playing with that and not really having a lot of expectations. You could work with a machine tool manufacturer or a machine manufacturer. If you've got an application you think's right, the manufacturer oftentimes will hold your hand, make the first part for you or parts for you. They'll probably charge you for it. So you've got some skin in the game, but they'd like to work with you to make the first parts. And they like to teach you how to use their machine so that eventually you could buy a machine. You could work at a makerspace. A lot of times there's local makerspaces that would have a machine you could use, either at a university or Cincinnati Public Library has a makerspace where you could learn about 3D printing. You could work with a national lab. I've had the opportunity to work with Oak Ridge, but Los Alamos and Lawrence Livermore and National Renewable Energy Lab all have 3D printing capabilities in certain applications and are cool to work with. Or you could work with a service bureau. Now, service bureaus are companies that are set up. They have oftentimes multiple different technologies of machines. They've got engineers that know how to do CAD and design for additive manufacturing. They know how to do programming. They've got a whole post-processing department, and they can probably make your part from beginning to end and kind of share with you a little bit about how they're doing it so that you get to understand the process.
Yeah, great points in there. And a lot of that is seeing, if it does have a benefit being 3D printed, or if you could do that in another way that might be a better way to manufacture what you're looking at. But you need to have the comparables and also look at where you might add some value inside of 3D printing if you're going that way.
And my favorite way to get started is to work with a consultant.
Hey, there you go. Yeah, talk about that. If someone wanted to work with you as a consultant, how would someone go about reaching out to you?
They can find me on LinkedIn. I have my own website, rickneffllc.com, or they could get a hold of me with my email of rick@rickneffllc.com.
Perfect. Yeah.
Any of those?
There's a lot of great things happening out there, Rick, and I know I do have a pleasure of talking to you, and so I'm glad we had a chance to sit down and chat a little bit more today. Is there something else you'd like to chat about while we have you here?
Oh, I just want to give some props to some of my other current customers, if that's okay. Doing a little work with CEED, stands for Connecting Engineering and Design, spelled CEAD. They make large-scale extrusion machines, mostly robot-based, and are doing a great job in the marketplace right now. MC Machinery, which markets Mitsubishi's laser wire metal additive system. They're just setting up an applications department and starting to consider selling that in the United States. That's exciting. Company G0 Additive Manufacturing makes a large, really productive fuse filament fabrication machine. They also do service bureau work. And one of my favorite customers, Additive Engineering Solutions, or AES. Some friends that do large format 3D printing and machining for both prototyping and production. They're in Akron, Ohio. They do large scale things really well.
Well, there you go. Well, Rick, thank you for joining me today, and always a pleasure. We look forward to seeing you soon.
All right, Adam. Thank you, man.
Thank you for listening to the All Digital Additive Manufacturing Podcast. If you would like to help support and build our community, take action and press follow, subscribe, comment below, or please leave a review. And don't forget to share. Thanks for continuing the conversation. This is Adam Penna signing off. See you soon.